All right, well, hello and welcome back to the Intermediate Algebra Final Exam Review Series. This is Joe Brownlee with Palm Beach State, and we are on question number 25, the halfway point. So let's go ahead and jump right in. And the directions for number 25 are solve the equation. Alrighty. And the equation they give us to solve is 128y equals the square root of 1 minus 192y. Alright. Well, I know if I'm being asked to solve the equation and I have variables, that at the very end I'm going to have my variable on one side and everything else on the other. So I'm looking for the solution or solutions to solve this equation. So I'll have y equals some number or numbers. Well, if I'm going to solve for y, that means I want to get it on one side of the equation, but right now it's on two sides of my equation. So the first step that I'm going to want to take is to get rid of this radical on the right-hand side. And the way that I do that is, of course, you'll remember by squaring. But I can't just square one side, right? I have to square the other side, because whatever I do to one side, I have to do to the other, so my equation stays balanced. And when I do that, I'm going to get 128 squared, which is probably a pretty big number. So let's get our calculator and see what we have here. 128 raised to the second power gives me 16,384. And then what is y squared? Well, that's easy enough. That's just y squared. And then on the right-hand side of my equation, when I raised the radical to the second power, the only thing that happens is my radical disappears, and I'm left with everything that was underneath the radical. So I get 1 minus 192y. Well, I can see then that this is now a quadratic equation. So why don't we go ahead and set this equal to 0 so that we can easily factor. And the way that I do that is I'm going to move everything from my right-hand side to the left-hand side and set this to 0. So in order to do that, I'm going to have to subtract 1 and add 192y. So let's go ahead and do this in one step so that we can go ahead and save a little bit of time. Alright, well, when I subtract 1 from both sides and add 192y to both sides, I get 16,384 y squared plus 192y minus 1 equals 0. Alright, well, now that my equation is set to 0, I can go ahead and factor this, but this is a pretty unique situation because our numbers are so large. So we probably don't want to scissors this because that would be a nightmare, and I don't even know if we could scissors this. I don't think there are any factors of 1 and 16,384 that subtract to give me 192. So let's go ahead and use the quadratic formula, which I don't think we've used yet in questions 1 through 24, but you'll recall that we can always use the quadratic formula to factor any trinomial. And so the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. All right. Well, we also need to make sure that our equation is in a specific form, and it's going to be ax squared plus bx plus c equals 0. And we can see that our equation is in this standard form. So now we can easily identify our a, b, and c. A, b, and c. Well, if we look at the form, the standard form, a is the coefficient in front of my squared variable. And so in this case, a is 16,384. Again, b is going to be the coefficient in front of just my single variable, in this case 192. And c is equal to my constant, which in this case is -1. All right. So now that we've identified our A, B, and C, all we have to do is plug and chug right into the quadratic formula. And I would beg you, when you are using the quadratic formula, please make sure you're using parentheses when you're plugging in. Otherwise, the signs can get a little tricky. All right, so we have x equals negative, plugging in b, which is 192, plus and minus the square root of b squared minus 4a, which is 16,384, c, negative 1, all over 2, and again plugging in for my a, 16,384. All right, I know this seems like a lot, but I promise that if we just take it step by step, it's going to be okay. And make sure you have your calculator with you, and I think we'll be just fine. So x equals, well, what's negative 192? When I distribute this negative, well, that's easy enough. That just is negative 192 plus and minus. What is 192 squared? Well, let's get our calculator out. That's going to be another pretty big number. Gives us 36,864. All right. Well, negative 4, when I distribute it to my 16,384, gives me, let's see, 16,384 gives me negative 65,536, well, times negative 1. Okay, so let's go ahead and figure out what is under this radical. All right, so 36,864 minus 65,536 times negative 1 gives me 102,400 divided by, what is 2 times 16,384? Well, that gives me 32,768. All right. Again, I know these are really big numbers, but I have a feeling that 102,400 is a perfect square. So let's see if I'm right. So again, we have negative 192 plus and minus. Let's go ahead and figure out the square root of 102,400. And indeed it is. It is a perfect square of 320 divided by 32,768. All right, let's grab another piece of paper here. All right, so then in reality, this is saying x is equal to negative 192 plus 320 divided by 32,768, and x equals negative 192 minus 320 divided by 32,768. So let's figure out what each of these is. So on the left, I have negative 192 plus 320. Well, that gives me 128 over 32,768. And let's see if 128 is a factor of 32,768. All right, and it is. All right, so we can reduce this. How many times does 128 go into itself? Well, it goes in just one time. How many times does 128 go into 32,768? Well, it goes in 256 times. And so x equals 1 over 256. So this is one answer that I've determined. And let's go ahead and figure out what the other solution might be. So we have negative 192 minus 320. Well, that gives me negative 512, again, over 32,768. Let's see if it is, let's see if 512 is a factor of 32,768. All right, and again it is. So how many times does 512 go into itself? Well, it goes in one time. How many times does 512 go into 32,768? Well, it goes in 64 times. So x equals negative, because don't forget this was originally a negative 512, negative 1 over 64. All right, so I have now two answers, and what I want to do is I want to go back and take each of these answers and plug them into my original equation to see whether or not they are valid. And I have a feeling that our negative 1 over 64 is not going to work, because when we plug it back in to our original equation, we're going to get a negative under the radical, and you know that we cannot have a negative under the radical. So let's go ahead and do it just to see what happens. All right, so we have 128, and you know what I did here? I was pretending I was solving for x, but remember originally it was y, so that's my fault. So we'll just go ahead and cross it out here at the last. So y equals. All right, well, if y is negative 1 over 64 equals the square root of 1 minus 192, and we'll plug in negative 1 over 64. Let's see what happens. Well, 128 times negative 1 over 64, that gives me a negative 2. And on the right hand side, the square root of 1 minus 192 times negative 1 over 64, all right, gives me a radical 2. Well, I have a problem, don't I? Because I have a radical 2, and then I have equals a negative radical 2. Well, that is a false statement. All right, I can't have a positive radical coming out as a negative. All right, so right away we know that we can eliminate our y equals negative 1 over 64 as a solution. But what about y equals 1 over 256? Let's see if that is a solution. All right, so I'm going to go ahead and plug in for my original. So I had 128 and 1 over 256 equals radical 1 minus 192, and then plug in. Well, let's see. On the left-hand side, 128 times 1 over 256 gives me 0.5, or a half. And then on the right-hand side, I get radical 1 minus 192 times 1 over 256 gives me 0.5. 0.5 equal 0.5? Yes, it does. So that is a true statement. And so even though we were able to solve for y and we had two solutions, the only one that is valid is y equals 1 over 256. All right, so I know that was a lot of work, but eventually we got to the solution. And so let's just really quickly, we'll go over this and put it all together. So they wanted us to solve the equation, and so what we did is we were trying to isolate y, get it all by itself. And so what we did is we squared both sides. And when we did that, we created a quadratic equation. So we brought everything from the right-hand side over to the left and set our equation equal to 0. But because this couldn't be factored using scissors, we used the quadratic formula. And so we assigned our A, our B, our C. And all we did was we plugged it in, did a little plug and chug. And finally, when we reduced as far as we could, we got y equals 1 over 256 and y equals negative 1 over 64. And we wanted to test each of these solutions to find out whether or not they would satisfy our equation. And when we plugged in negative 1 over 64, we got negative 2 equals radical 2, which is a false statement. And so we dropped y equals negative 1 over 64 as a possible solution. But when we plugged in our second solution, 1 over 256, we had 0.5 equals 0.5, or half equals half. That is a true statement, and so that is the only solution that we are going to keep as our answer. All right, well, I hope you stuck it out with me. That was a long one, but this was question number 25. We are going to move right along to question number 26. Again, this is Joe Brownlee with Palm Beach State. Thanks for watching.